What is up, everybody? Thank you so much for tuning in to another episode of the Anti-Gravity Group podcast. My name is Braden Carlson.
My name is Taylor.
My name is Shane, or as you might know me, Postart.
My name is Matthew, or as you may know me as Macho Matt, probably.
And I'm Bryce Chanes.
That is right, guys. We have full house today. 5 people and another guest. Tripoli Board of Directors member and famous for the Sasquatch 24-inch Mad Cow squat, Bryce Chanes. How are we doing today?
Good.
Before we dive too far into the topic, I know a lot of people have specifically asked me, actually, so I figured we set the record straight here. Is the Sasquatch going to be rebuilt?
Absolutely. 100%.
All right, good to know. Yeah, like I got a bunch of messages about it. I was like, I think so. I don't know. It's not mine. But yeah, okay. Well, good to know.
Yeah, suffice it to say it's not going to be repaired as there's nothing left. So it'll be a complete rebuild from start to finish with a bunch of improvements and going to keep flying big fat rockets for the future.
But the 6-inch motor case survived, and that's what really matters.
Yes, it did matter.
All the scaffolding in 24-inch tube was really like a pillow for the motor case to survive.
Like crumple zone. Exactly.
Crumple zone.
Yeah.
Nice. Did the funky size tube survive? I don't remember the motor tube.
It did. So the official parts that were retained for this project were, so the motor case survived. The motor mount tube, which as Braden mentioned is kind of interesting because it's a Pro 150 sized fiberglass tube. So it's 6.33 inches. It's a weird size. The electronic sled was found and a couple of the terminal blocks were ripped off. So I think the electronics will survive. And that's the fins actually were the other part that survived, but I didn't keep them. Another flyer on the site kept them. So maybe there's going to be an East Coast Sasquatch.
Or maybe they just wanted to go sledding because things were huge. All right, well.
Table.
Yeah, oh yeah, there you go. The Sasquatch end table. That's not a bad call. So we've had many requests to do an episode on research and making your own rocket motor propellant. And there's 5 people in this chat right now, and there is 1 person qualified to discuss that. So we figured we'd bring Bryce in for this one, somebody who actually has a ton of experience on this subject and is actually working on a class so that you can learn to mix propellant. So I can't think of a better person to have to, dig into it. So we're going to try and keep things mostly surface level today, but it's sort of what's it take to get started? What kind of materials are you going to need? Tools, like a general estimate of what the upfront startup cost is. So with that, I'm going to hand it over to Bryce, and then we've got quite a few Patreon questions about rocket motors. So
yeah,
it's your time to shine.
Do you want to go and start with some of the kind of questions you had right off the top and kind of use that as a kind of going forward, what topics we want to cover in terms of experimental motors? Because there's so much to cover. This is not a tutorial. This is not you'll be an expert after this, right? But hopefully we can help identify some resources and get you guys started thinking about what kind of stuff you would need to get started in making your own motors.
Yeah. So do you want to dive into Patreon questions? Or are you curious what I'm curious about?
I think let's get started with some of your questions. I think your questions are probably better to steer the conversation with.
Okay, cool. And I'll have the co-hosts of the round table throw their questions in as well. I know Taylor and Postart both have equally burning interest in, no pun intended, making our own propellant. So, but I guess as far as, mixer and sizing and vacuum chamber and everything, what do you consider an essential sort of power tool starter set for mixing propellant?
Yeah. So when getting started making your own propellant, and I should preface this whole conversation with the fact that everybody does things very differently. There's no exact right way to do it. There are some wrong ways to try to steer away from and avoid. But you hear stories about people like Tony in California, mixing motors by hand, up to, even O and P motor sized projects. So in terms of like, just getting started, what we always suggest, and what I always suggest people do is find a local mentor, somebody who has all of the equipment and more that you could use in the kind of learning stages of experimental motor making. So you don't need to go out and buy a KitchenAid mixer on day one. Your mentor is going to have a mixer available for you. You don't need to worry about casting supplies and mandrels and cleanup equipment and anything kind of associated with the mix in terms of the tools and equipment. You're going to kind of just rely on standing behind your mentor and having them kind of guide you through a lot of that. And that breaks that first barrier down. Your first EX motors should basically be the cost of your materials. Find out, what things you want to do, where you want to go with that side of the hobby. And you don't have to go all in on $1,000 worth of KitchenAids and special mandrels and mold releases and a whole bunch of the kind of side paraphernalia that you might need in order to kind of make motors at scale. You can, mix with friends, mix with a mentor, learn kind of hands-on what goes on during a mix, and focus your investment in where you need to, because you may find out that maybe it's not that interesting, maybe it's more fun to do with people anyway, and your mentor's a cool guy, and it's just going to be so much cheaper and more fun to mix with a friend. Those are some of the starting things, but you don't need to start out with a KitchenAid. If you're ready, if you've done the research, you've gone and done some mix sessions with a mentor, sure, getting a small 5-6 quart KitchenAid mixer is a great start. I don't suggest buying one new. It just doesn't make sense. You're going to be taking this one out of the food market anyway. So, grab the used one on Facebook Marketplace that runs and drives, and you'll be good to go to start. You're going to use kind of the regular, not the whisking paddle, but the kind of, almost like a hand shaped, like a normal beater paddle.
Take batter one.
Yeah. The kind of common use, the one you use for making most of things with. And that's going to be you're kind of using that as a tool to help prevent you from doing this action for hours on end, right? My first EX motors outside of a mentor was a stainless steel mixing bowl and either a wooden spoon or I call them spurtles, but they're these rubber scraping spatula devices.
Oh yeah.
And making small batches by hand up to maybe a pound or two at a time is not that bad to do by hand. And Tony and others have put out resources online that you can go find that walk you through some of the steps. And in fact, in Terry McCrory's book, which I brought out because we're going to have to talk about the experimental composite propellant book for a little bit. But Terry's book outlines kind of a cool process for making really small batches of propellant, sub 50 grams, 100 grams even, where you just mix everything inside a Ziploc bag, which is pretty cool. I'll admit I haven't done that before, but it's a great, helpful first step if you're interested in just dipping your toes in to making your own motors.
Yeah, and that's actually a good segue into another question. I know a lot of people have, like you said, the whole mixing in bowls versus a mixer and everything like that. I have made one EX motor in my life as a teenager. I made it in a giant dollar store plastic bowl with a friend in Idaho who was mixing propellant in his garage, and his turned his level 3 rocket into confetti, and I had no intentions of flying the one that I made with him, and then I flew it and it worked because he passed away, and it was a whole thing. He was giving me hell while he was still alive for being scared to fly it. So I was like, okay, well, fine, let's do it. Anyway, what he started me at 75 because he was already making a 75 millimeter motor, and his argument was that starting with 75, if you have the hardware handy, is a good place to start because a bigger diameter makes for less mistakes potentially. Where do you stand on that?
Yeah, there's definitely, an element of truth to that, right? There are a number of ways that making your own propellant can uh, have small issues. Mostly we talk about things about voids having small bubbles, porosity, low density, those kinds of issues at a larger scale, say 75 or larger, tend to affect the motor's performance significantly less than they would at a smaller motor size. So if you imagine like a 1 centimeter sized bubble, a pretty big sized bubble on a 24, 29, 38 millimeter motor could mean that the increase in surface area of the propellant is going to be very large, whereas the percentage increase will be large versus on a larger size. Now, that being said, step one, if your mentor is making 75 millimeter motors, make 75 millimeter motors. If you're starting on your own, it's super common to start with things like a 2 or 3 grain 38 millimeter motor size. I like starting, if I can, at 54. That's where most of the students that I'm teaching start out with, is making a couple 2 to 4 grain 54 millimeter motors. It's hardware that I have available. It's casting equipment I have in large quantities. It's not really too much more expensive to do so. But yeah, the bigger can be more tolerant, but of course you're putting more money on the line, right? If you're gonna have a problem and it's a 38 millimeter motor, the cost associated with the hardware is going to be significantly less than it would be if it was a 75 or 98. And so, just like with all of our projects and all of our rockets, you never want to put something on a test stand or put something in a rocket you aren't financially able to lose. And especially when making your own propellant, the consequences can be, total losses of your vehicle, hardware, damage to launch pads is not uncommon. And they're not like more common, and we can talk about this more later, but it's not that making experimental motors is more risky. But there are failures that come about from not knowing enough, making mistakes, quality control, those kinds of things that would affect even a commercial motor, just become amplified when you are in charge of the entire production process.
Cool.
Braden, I just want to ask kind of maybe an obvious question. Are we talking mostly about ammonium perchlorate? Yeah, solid fuel motors. Okay. So I figured that's basically what this whole discussion.
Yeah, and I will say, personally, my experience is in ammonium perchlorate propellants. This is not the only way to do it. Of course, everybody's probably heard of rocket candy or sugar propellant. There's a whole vast network of resources for doing so. And a lot of the same advice does apply. Some of the equipment is different. We talked about mixers and that kind of avenue, whereas for sugar, you're dealing more with hot plates and heated bowls and other kinds of heating devices. But I will admit, my personal experience is not in sugar. I've not made a sugar motor. I'm not particularly interested in it for a lot of reasons. And so I don't have a lot of hands-on experience with it. So
Makes sense.
I think Taylor and I both have a similar young us story of ruining a frying pan in an attempt to make our candy. Is that right, Taylor? You did that as well?
I don't know if I ruined a pan, but I definitely made a lot of smoke bombs and sugar propellant as a teenager.
Yeah. Did you ever cook it, or you were just doing loose powder?
Oh, I cooked it. Yeah.
Yeah.
I was making art candy and stuff.
Yeah, I kind of sacrificed the pan that I learned to fry eggs in as a child and repurposed it to make sugar propellant. My mom was not thrilled. So if I can offer one piece of advice so far in this podcast, it's don't do that. When it comes to listening or making motors of any kind, even with Bryce's limited experience of at all, if he has any in sugar, listen to him instead of me. He's going to have way more politically correct answers.
Yeah, I'm always dubious of any process that involves having to heat something that is naturally capable of setting fire. So
yeah, even prone, I would say.
Yep.
Quite flammable.
And I want to be clear, it can be done safely. People have a lot of fun doing sugar motors. There's significant potential for cost savings in doing so. The ingredients to make sugar motors is a lot less than it is for ammonium perchlorate motors. That being said, that's just not where my experience is. I've never had a mentor that has done sugar. So if I was interested, that's where I would go start first.
Yeah, a lot of college students wind up with sugar motor experience because of Rick Maschek out at FAR. So there's a lot of sugar propellant being made safely and functioning just fine. So yeah, you're correct. But okay, so let's say you've got your mentor and you're ready to sort of branch out on your own. We've made a lot of rocket motors with our mentor. I'll remind everybody, we're not just diving in and ordering a bunch of stuff. I know you're, Bryce, kind of a champion of finding incredible deals for things on Facebook Marketplace. Actually quite inspiring to me. When Shane and I moved to California, I was like, I'm taking the Bryce approach, dude. I'm not buying anything new. I got an end table for my 3D printer for like $5, and I was all over town instantly. I was loving it. So that in mind, what is sort of like a realistic budget, if you can land on one, or even a range to say, this is, I need safety equipment. I need, if I'm getting a mixer, a 5 or 6 quart KitchenAid, like you said, and all this stuff, chemicals, everything.
Yeah, I think a pretty comfortable starting place is roughly $1,000. If you have $1,000, you should, at least in 2024, be able to start making motors, be able to buy ingredients in a quantity that makes sense, right? You're never going to be able to buy 1 pound of ammonium perchlorate. You're going to buy it in 10, 20, 50 pound buckets. So, there's significant, investment as part of that $1,000 subset. It's probably half in materials and about half in chemicals, because you're going to need a lot of stuff. There's no getting around the need for the binders and for the curatives and plasticizers and various powders. Assuming you're going to stick to just one formula, that's going to get you started. It's very quickly will snowball from there as you decide, hey, there's another formula I want, so I need a couple extra ingredients here. Hey, I want to change to a different motor size, so I'm going to have to get some casting equipment here. If you've got tools like a 3D printer already and some general shop safety equipment, glasses, dust mask, a fire extinguisher, those kinds of things, you're off to a good start. If you're mixing epoxy safely, you can mix motors safely as well. And we can get into the safety stuff in more detail later, but having a place to do it safely is also probably one of the biggest barriers to entry. A lot of people come to me and visit my shop here and mix motors here because I have a safe place to do so. And if you live in an apartment, a condo, don't have an open air building that you can work outside safely near a high ventilation area, that kind of thing, then you don't have a place to mix motor safely. And you should be smart enough to know that's a limitation, and you should find friends that have places to do it. You're gonna make a lot of friends along the way, and you're going to learn a lot from other people too. And I always take every opportunity I can, if I'm traveling places, to go and mix with other people that mix and learn, hey, how is your setup different than mine? What equipment are you using? How are you handling this material? Why do you do it this way? I ask a lot of questions, not to judge them or tell them that they're wrong or different, but just to learn how everybody does it. East Coast mixing feels very different than West Coast mixing, just because of the kind of natural progression, that tree of mentors that has grown and shared their knowledge throughout the types of propellants and types of equipment people use.
Yeah, there's definitely no shortage of stories if you've been around rocketry as long as you, myself, and Taylor have, of hearing some people in our age range mixing motors in some very interesting locations that work against the you should know that's a limitation thought process. But everybody made it out okay. But yeah, do heed that advice, please. All right. I'm curious. I know Taylor has talked a lot about once he has a place to do so, mixing propellant. So, do you have anything here, Taylor?
I guess, am I right in saying, or like the propellant processing is one of the most important factors? Would that be correct? I mean, you need to have a very consistent process.
Yeah, I think the key there is the word consistent, right? I actually, this is perfect timing. Last month I was at LDRS and gave a presentation as part of the annual Trade Tech conference where I posed an experiment last year and said, hey, what if we all tried mixing the exact same formula? And, this is just open to the rocket community. Here's a formula. Let's all mix it. Let's all test it on our own equipment and let's compare the data and see how different is your motor that should be exactly identical to my motor? How different are they? And what we saw was a huge variety of motor performance for the exact same formula with the exact same ingredients. Now, there are dozens of key variables, but the main one is processing. And I say the main one, that is going to be another experiment to determine, hey, if we all have the same ingredients from the same batch of ingredients, we're not buying it from different sources, how does that play a role into the performance differences? But there was a pretty prevalent comment you'd see online of people saying, hey, I don't want to share my formula because the way I make it and the ingredients that I'm using are going to affect the way the motor performs. If you just take my numbers and you take my formula, your motor's not going to be the same, and you have an elevated amount of risk if you don't test it. And so I wanted to put that to the test. And the answer came back pretty clearly, yes, it is a big difference. If you don't characterize motors, meaning you test it in small sizes in order to kind of determine the propellant's performance, it's going to be different. And different's not bad. The fastest burning version we saw and the slowest burning motor, it wasn't it wasn't a problem. But the key was they were different, meaning that your consistency matters. That when you make a motor, you're making the motor the same way every single time. You're using the same process. You're trying to eliminate as many additional variables to try to prevent new problems from cropping up. It's absolutely a key to making your own motors.
Is that
And
presentation? Oh, sorry. Go ahead, Taylor.
For long-term, like, if the goal is if I wanted to make the most consistent motors and have them scale nicely and stuff, would it be important to start with vacuuming the propellant?
Sure.
Is that something you need to do from the beginning?
Sure. I mean, need is a pretty strong word here, just because, again, the key is consistency. So if you want consistency,
I guess
it can be a lower quality propellant. You can have small voids, you can have small issues. If they're consistent, you not just learn to deal with it, you'll be agnostic to the differences as you scale up.
Yeah.
And one of the ways go ahead.
A better way to put it, I guess, is it possible to make a consistent repellent and increase and make larger motors that without using vacuuming processing?
Sure. Yes, is the short answer. Absolutely. It's not a requirement.
Yeah, okay.
You can make big motors. I was talking earlier, I'll point to Tony out in California again, is a great example of somebody who I'm not even sure to this day he owns a vacuum chamber and has made thousands and thousands of pounds of propellant without issue. Now, if your goal in the hobby, in the propellant making hobby, is to develop propellants that are really intense, high performance, right on the cutting edge of aerospace development, like if you're trying to make the next C-Star, IMAX, better versions of those, you're going to want to vacuum process, and meaning you're going to want to pull out as many voids as possible. You're going to want to cast maybe even under pressure, so that or cure under pressure, so that the propellant is as high density and consistent as possible. But if you're not if you're in the hobby to learn things that are not performance driven, then no, you don't have to mix with vacuum equipment. Not that vacuum equipment should be a very strong barrier. Picking up a Harbor Freight vacuum pump and a piece of acrylic to be your lid, it's pretty low cost. It's definitely going to be under $100 for most people to make a vacuum setup capable of their like KitchenAid size stuff.
Yeah, I bought one on eBay. The brand is like Viver or something like that. But I was like, let me see how good this is. I've only used it for epoxy, but I think it was like $78 or something like that. It's a 5-gallon bucket, and so far it pulls plenty of vacuum. Gauge says so. So I don't. I feel like it would be plenty good enough for small stuff. Not like you said, not high stakes, real fast, heavy hitting propellant, but I think it would get the job done if we were to go that route.
Yep, absolutely. You definitely don't need a fancy 2-stage, medical grade vacuum pump to accomplish the objectives that you need. So.
Okay, so I do have a bit of a transition here, but before I do that, I want to see if Matt or Postart have anything for you, sort of on the topics we've discussed so far.
I've had most of my questions answered. I mean, there's not a whole lot that I know, so a lot of this I'm just along for the ride, trying to learn.
Just more of a personal question for me. Say you get rolling making propellant. I feel like the like a KitchenAid is sort of where everyone starts, kind of, if you get your own personal mixer. Say you're kind of reaching a point where you outgrow that. What do you personally think is the next like preferred size up from that? Because I've heard a lot of people say, I like the 12 quart, but other people say 20 quart. Skip the middle size,
Yeah. So to let people know, if you have a 5-quart mixer, you're probably maximum capable running really hard that thing at maybe 5 pounds of propellant. So every time you run that mixer, if you fill it all the way up to the limits that you're starting to really heat up that motor, the motor, the electric motor in the mixer, that is, then you're looking at maybe an M, right? Like a baby M, big L, like in terms of every batch you make, that's going to be your maximum impulse. So you can think, hey, if I'm trying to fly an N motor, right, that's going to be at least 4 of those batches every time that I want to do an N motor. Or I guess 4 to make a full N, 3, 2 to 3 anyway. You're going to need multiple batches to make that. And if you're starting to run into a time crunch where you are like, hey, it doesn't take any different amount of time, generally speaking, to make a batch in a 20-quart mixer as it does to take a batch in a 5-quart mixer, but I get 20 pounds of propellant instead of 5 pounds of propellant. Is the cost associated with buying a 20-quart mixer, servicing a 20-quart mixer, feeding a 20-quart mixer? We kind of joke about that, but mixers have a minimum batch size as well. You're not going to be able to make your 38 millimeter, 2 or 3 38 millimeter eye motors in your 20-quart mixer. You're going to have to run the small one. So it's always nice to kind of have a few in line with one another. In terms of 12 versus 20, what do you have available? What did your mentor get rid of that he didn't want anymore, or somebody else in your area getting out of the hobby? What did you find for really cheap on Facebook Marketplace, right? If you're starting to make O's and P's, and that's something you want to do every year, you're going to want to look at the biggest size that you can comfortably fill up and afford.
Awesome. Yeah, I know there's a couple people that are really on the don't even buy a 5. Just if you're gonna do it right. Get a 20. And
yeah, 5 is a perfect place to start. 5 or 6. The normal KitchenAid mixers. If you can find one with the drop bowl versus the tilt head, people have their own preferences for what they want. You pick your favorite color; it doesn't matter. Find for me, my suggestion. I mean, Braden, we've talked about this before. Find what's free. Find the guy. Find the person getting rid of something. My my 5-quart mixer was free. It's kind of crazy. My 60-quart mixer was free. You know, and they come from
God.
other hobbyists. They come from people upgrading or downgrading, and you know, these kinds of equipment change hands all the time. And so, you know, at some point I'd like to get something in the middle, between my 5 and my 60, because 60 is a lot. And it's 800 pounds is that mixer, like in size and mass. Like it is a huge piece of
God.
equipment, and a huge investment every time I go to spin it up. So it's you know, it's not lost on me that, yay, I can mix, you know, 2 O motors in a batch, no problem. That's great. But now I'm spending how much on ingredients, and what's my, you know, all the other equipment that goes along with that. Having the capability does give you the opportunity to make more big motors, but I also want to be sensitive to, it is very hard to make small motors with a very big mixer. And that's something that's really important that I'm learning to deal with right now.
Yeah, that's actually something I was gonna say I've never really thought about. Like you said, feeding a 20-quart, you can't just whip up a couple I motors. But yeah, it was actually really great. A friend of mine in Idaho who was mixing a lot of 6-inch stuff had a real big mixer, so he would pour his 6-inch grains and then just pour a bunch of 54s and 75s. So he handed out motors all the time. That was awesome.
Yeah.
But
and once you get to motors that size, kind of the scrap and the you know, the scrapings, as you call them, right? Like become big, you know, big motors to a normal person, right? I mean, my 5% of the batch I'm about to mix this weekend, you know, is you know, a couple of J or K motors, and like that's you know, to me that's extra, and I'm going to use it, and I'm going to get it all cast, and obviously try not to let any of it go to waste. But those waste become motors that, you know, to me don't have a value directly because I was focused so heavily on the big motor that I was casting.
right.
And it's also really important. We didn't get into, by the way, how I got started or what I do for a day job, right? Which is making motors and dealing with you know, research development for solid propulsion services. And so, with that being said, I take a very professional approach to the way I design and mix and cast motors that I try to teach, or at least suggest, if people have the opportunity, hey, when you go make a giant motor with your giant batch, mix some small motors and do some characterization and test each of those motors every time. When we have a 300-gallon batch at work, and we cast motors all day long for professional contracts, the first motors off the line are little tiny test motors. Halfway through casting, we cast another set of little test motors, and at the end of the casting, we set aside a few little test motors, and we test all those before we even allow any of the other motors to escape or get tested. And so that's, you know, really critical. And I'm starting to dive even more into the scientific aspect of research. And that's what keeps me really interested.
Yeah, it is a whole, it's not just an element of rocketry as a hobby. It is in itself another hobby, undoubtedly.
Yep.
Yeah, I actually wanted to talk about your background a little bit there for a second, or at least address why we didn't dive into it, because I knew this was going to be a long-winded topic. But we would love to have you back for another episode, much like we did with Joe, where we kind of just tossed him into a game, and then we're like, you know what, why don't we ask him about how he started flying rockets? So
sounds good.
If you'd like to come back, it'd be great. But Matt, you got anything before I take this shift?
No, that was basically exactly the question I was going to ask. What's your background and how'd you get started? But it sounds like we'll save that for another time. Is that right, Braden?
Yeah, well, it's
Okay.
I mean, you can touch on it real quick if you want, but we can dive into deep on another episode if you're down.
Yeah, maybe in a quick snaps. You know, what would you go to school for? If you went to school, and how'd you get started in rocketry?
Yeah, sure. I'll give the 60-second story. Is when I was out on a Boy Scout trip, we went out to a small little rocket club called the Rocketry Organization in California, and we had the Lestis rockets, and we were just expected to go fly those, but there were all these people with these high power rockets, and I thought that was the coolest thing ever. So I got hooked flying high power That was back in 2009, and I've been flying high power essentially ever since. I came back the next month and did my junior level 1. Have been flying all sorts of crazy nonsense, from high and fast to low and slow. Kind of love a little bit of everything. I'm always intrigued by whatever I can learn. Professionally, for school, I went to Embry-Riddle Aeronautical University in Prescott, Arizona, where I got a bachelor's degree in aerospace engineering. Always, from day one, it was rockets, rockets, rockets. So being able to do satellite design, being able to start rocketry teams and fly rockets on a regular basis was really fun. I helped start the solid rocket motor program at that school. That was in the 2014, 2015 timeframe. Now they're pretty accomplished, not in solids, but as well as in liquids engines now, which is pretty cool. In 2017, I started looking for a job, and early 2018 started with a company called Raytheon Technologies. Now Raytheon
That's
Technologies, and have been doing solid rocket motor design and development ever since. And living
awesome.
the dream job, doing rockets during the day and doing rockets all night long too. So
Yeah, love hearing the passion. It's awesome. Very cool.
thank you.
I had to get the soundboard out. Yeah, it's interesting because I think, Bryce, you're probably, of all the teenage Rocketeers of our era, you're probably the one I was most closely connected with and have known the longest. But yeah, Matt, Bryce is one of the people I got to watch ascend to the career path that I thought I wanted, and I kind of was like, I'm gonna go write about cars actually.
That's awesome.
So-
way to be living the dream, though, Bryce. That's awesome.
So we've talked a little bit about what is and isn't required in vacuuming and a mixer and all of this stuff. I want to talk, like you said earlier, about safety stuff, because that's kind of a non-negotiable. Not kind of, that is a non-negotiable item. So, or items. So what are absolute musts? I know you see a lot of people like just kind of doing rubber gloves and like a basic surgery mask, and I've seen a lot of sketchy stuff over the years. What are the actual essentials?
Yeah, so in terms of mixing safety, everybody has their own kind of take on where they want to associate risk, and so what kind of level of risk are they okay with taking on themselves? And what's important is knowing what the risks are and choosing yourself what you feel is the best approach for that, right? We should always be wearing gloves for lots of different things that we do in our normal lives. We should be wearing masks a lot more than we do in our normal lives. But especially in mixing, it's a matter of knowing what those risks are. In this case, we're dealing with a lot of chemicals. So if you don't know what the MSDS or the SDS for your materials are, you should have a notebook or a binder or a spreadsheet full of all of the ingredients that you commonly keep on hand, what their safety precautions are, what are the risks with using them. And you'll find that in general, most of the ingredients that we use in a normal, and I'll put normal here in a second, what that means, but in a normal, ammonium perchlorate based motor, there are very few chemicals out here that are really trying to kill you, which is great. There's a reason that we use them. One of them is that they're just not inherently super dangerous. But that doesn't mean that they aren't dangerous in prolonged periods of time or in acute quantities in general. Some of the major risks of making your own motors, like in terms of safety in the shop, you have the general fire risk, right? You're mixing an energetic material, something that can catch fire and has all the elements of the fire triangle right there. It doesn't matter what fire extinguisher you're using, where you mix propellant, where the ammonium perchlorate meets your aluminum, meets your HDPV, where that happens needs to be in a place that it is okay to burn, because you're not going to come back to save it. You're not going to dump water on a fire that is burning metal. It's not going to help. It's going to make things worse. Your typical fire extinguisher is just not going to handle that. So you need to have easy evacuation strategies. Your fire extinguisher, when I tell people I have one, it's going to sit right here by the door. It is not for the propellant when it's on fire. It's for the workbench afterward that's on fire.
Right.
It's for the table. It's for the other things that are on fire after the propellant has gone out. Another major risk during mixing is dust. So we're mixing powders that are very fine. We're mixing other solid material that is very fine particles, some in the sub 5, sub 3, sub micron particle size. And you're going to want to wear mask protection, and you're going to want to mix in a way that limits the amount of dust. And so we always recommend, hey, when you have that, solo cup full of aluminum powder, get really close to the bowl and try to pour it out. Don't just dump it out and have all this dust flying everywhere. Try to get it as close as possible. Go with that spurtle or spatula and mix it up by hand so that it's nice and wetted out before running your mixer. Because if you throw the mixer on and puff, all goes your aluminum powder, not only is it not making its way into your propellant the way you think, but it's also making its way into the air that you can breathe. And so whenever the dry materials are out, I always have a mask on. I have a like woodworking style, like ventilator style mask that I use. If you're okay with something like an N95 and some of the other kind of precautions, like I mentioned before, those are great. The other main ingredient people always talk about is the curative. It's usually a diisocyanate curative. And I should say, I'm not a chemist. I deal generally with chemistry, but I have chemist friends that I deal with for particular issues. And with the curative ingredients, it's not great to breathe, but it's also something that's common in a lot of common household objects and goods. When you use wood glue, it's going to have isocyanate curatives, and you're going to have epoxies. There's going to be other, resins and stuff. And so being cognizant of the fact that these are in the air around you is pretty important. We're going to get to, I think, some of the comments that include a question about tepanol. Tepanol is another ingredient that in and of itself, don't eat it, don't drink it, don't try it. But what it does do is it produces ammonia as a outcome of its chemical reaction that it's having with the ammonium perchlorate. And that ammonia is obviously very strong and very concentrated. And so again, back to having lots of ventilation, making sure you're not mixing in an enclosed area, dealing with the ammonia aspect of it can be pretty strong sometimes, especially in really big batches. It's not just, hey, yeah, kind of, haha, it smells like cat pee. This is like, high concentrations of ammonia, and our bodies are really good at detecting really small amounts of ammonia. So what's really strong may like numerically not actually be that harmful, but it's a good indicator of the processes that are going on. And if you're commonly smelling it and it's getting strong, you should make sure that you up your ventilation, whatever that is. If that's pulling out a box fan to get it farther away, opening more windows, whatever it is, you shouldn't be mixing inside pretty much any time anyway. And so that's some of the safety stuff. Again, everybody has their own preference. I mixed with somebody who is really anti any synthetic clothing while mixing, because if you were to burn yourself while wearing synthetic clothing, it's not going to burn off, it's going to melt on. And that can be obviously very dangerous. That being said, I personally don't feel like it's a major risk to me when I'm mixing. And so I don't necessarily go through like a clothing check every single time. I have it as a note in my mix sheet to ask myself the question. And if that's something I want to do at that point, I can switch out for cotton clothes and keep mixing. But like I said, everybody has kind of a different level of tolerance for what they accept as being normal. And the most important thing you can do if you're starting to mix motors is to be smart and know as much as you can about the ingredients you're dealing with. What does the SDS say are the risks and concerns, and how do the professionals want you to deal with it? And then you can make informed choices as an adult about how you move forward.
It's interesting. It was a lot more of a it's sort of open to interpretation answer than I was expecting. But I guess at the end of the day, that's kind of how everything is. But
Yeah.
Personally, I would love to come take your class. I know Postart's really interested in it as well, and I think we're probably gonna. I mean, you're the guy designing rocket motors for a living, so your safety protocols would probably be the ones that we would adopt.
Yeah, I definitely err on the side of more cautious than not. And that's the way I do things. I try to be as professional as possible within the realm of reason, because unfortunately the professional world sometimes will get sucked into really really intense safety protocols that stopped making sense a long time ago. But that's okay. They have a lot of other concerns and constraints that they're dealing with in that. There are also ingredients. We didn't talk about this. Every motor uses different recipe. Some of the main ingredients to stay away from. You don't see a lot of experimental motor people making green propellants, meaning motors that produce a green flame. Those tend to be barium based. Which is really, your body is really good at absorbing barium-based components, and it's not really good for you in any way, shape, or form. But just like when you mix epoxy at home, are you always wearing gloves every single time because you can get that epoxy allergy or other, the chemicals in that aren't great. So there are a lot, when you spray paint, do you wear a mask every single time you do that? Do you wear gloves to get it off your hands, right? All of these are like questions you should be aware of asking yourself every time you do any sort of hobby endeavor. But in propellant mixing, you want to know ahead of time and be prepared to address whatever safety concerns you personally have.
Yeah, that's in that light, I've definitely adopted a lot more masks when sanding and painting, and boy, do I get talked to about it if I'm in a video and not wearing a mask for any of that stuff, as I rightfully should be called out, especially with fiberglass. That's just dumb. But anyway, we've got a bunch of Patreon questions, but I did want to see if there's anything else, Bryce, you wanted to highlight first, or if you want to touch on Professor Terry McCreary's book, which I believe I just pulled up in a tab. It's available at Aerocon, Apogee, and a bunch of other places.
Yeah, it used to be on the tripolistore.com. I don't know if that's still active at all. But yeah, shout out to Dr. McCreary here. You probably, your middle school and high school textbooks could have been written by Dr. McCreary as well. Terry has kind of compiled a wonderful set of relevant information for the hobbyist in the book. We just call it ECP for short, but experimental composite propellants. There is I believe a PDF online that you can find of the first edition, but I promise that it's worth getting the second edition, not just to have a physical copy, support the guy that helps make this available to you. But also there's an emphasis in this book on HTPB based propellants, which is what 99% of the ammonium perchlorate motors these days use. Whereas when the first edition came out, there was still a plethora of leftover ingredient called PBAN, which was used in the space shuttle boosters, and you'll see it in like legacy formulas, but it's darn near impossible to get. And if you do get it now, it's from the 80s anyway, so it's probably not good. So this has been updated. It has a lot of great information. If you read through this and you understand the stuff here, or if you read through this, have questions and reach out to me about them. There's a whole section here on safety. There's a whole section on testing motors. Some recommendations on how to get started. It's really a one-stop shop for getting a primer on, learning what questions to ask. I'm always afraid of people not asking enough questions because they don't know enough to ask good questions. If you read through ECP, I promise that you will have 100 questions that are good questions to be asking. And it's just an awesome resource. Shout out to Richard Naka's website as well, as for an online place to learn a lot about the fundamentals of solid propulsion. There's some questionable stuff there. There was a lot of sugar propellant information as well, which is great. But there's also a lot of propulsion basics that are really, really valuable to get under your belt before you start designing your own motors.
Awesome. Well, shall we move on to fielding some of these Patreon questions?
Let's do it.
All right, we're gonna start with Bryce and Nicole Chanes. Asks, where does he get his good looks?
Hey, yeah, my mom and dad, it turns out.
Yeah.
All right, Rocket Profit, who, by the way, congrats to him. He won the $200 Wildman Rocketry gift card from the sticker sale that we just had, and he bought a 3-inch Punisher, which is about the best way you could spend that $200 if you ask us around here.
Well done.
He says, does vacuum degassing really make that much of a difference to the performance of the final product, and why?
The short answer is, does it make a difference? Absolutely. You would notice the difference if you took half the batch and didn't vacuum it, and you took half the batch and you did vacuum it. The difference you'll see is a lot higher density. So the propellant itself will be denser, meaning there's not as much air pockets going on. And I should explain, when we pull a vacuum on the propellant, what we're doing is we're taking all of those bubbles and we're growing them in size. If you've ever seen anything under vacuum, like a marshmallow under vacuum, it kind of inflates. And then once it's done, all that air has basically become so big that all those bubbles have popped. And then once you release the vacuum and put pressure back on, everything shrinks back down to a much smaller size than it was before. And so you can think about it like that, where all of the bubbles in the propellant are growing, then they pop, and then you release the vacuum and everything shrinks back down, and you're left with a propellant that is a lot less full of bubbles. It's a much nicer propellant. And, that is the performance difference. You're going to see that your motors are going to perform higher because you're going to get more propellant in the same volume, right? If your propellant is half air, you're going to lose half your impulse. So that's the difference. And performance wise, you'll probably have a slower burn rate. Air creates these little pockets, and so it's going to artificially enhance your burn rate of the motor. So you could actually read about old papers where people foam their propellants and try to put as much air inside it as possible to try to artificially increase the burn rate and make it go really, really quickly. But generally, we don't want that. Generally, we want no bubbles. And to Taylor's comment earlier, if your goal is consistency, nothing is more consistent than not having any bubbles at all.
Cool. And he asks, please explain the pros and cons for using different ingredients to either accelerate or slow down the burn rate of different propellant formulas.
Yeah. You can make fast motors and slow motors, just like we have Warp 9s and Smoky Sams, right? You've got a whole wide variety of things, and the way you do your own experimental hobby is going to be up to what you want to do. We have really cool experiments going on right now with people playing around. We'll talk about wires and chopped fiber in motors later in some of the questions, but people playing with really high burn rate propellants because they want to work on end burners, or they want to work on motors that have a very high thrust. Some people really want to slow down their burn rate and keep the rocket going as slow as possible. And so you're going to add these burn rate suppressants that are going to keep things nice and slow. And there are dozens, if not hundreds, of chemicals that do all this. Common burn rate enhancers, things that are going to speed up your burn rates, are a lot of metal oxides, copper oxide, red iron oxide, yellow and black iron oxides. And some of the common burn rate suppressants would be things like oxamide or melamine or a couple other ingredients that can help slow down your burn rate. And it's a matter of picking what you want, right? Do you want a fast motor? Do you want a slow motor? There's nothing wrong with either one. You could do nothing. You can leave them all out entirely and just stick with whatever vanilla comes out that way. A lot of these enhancements also come with color changes as well. Copper oxide, I mentioned before, is the prominent blue color you see in Blue Thunder. Let's see, strontium nitrate is other strontium compounds are the reds that you see in Red Lightning and Red Line. So yeah, it's, what do you want to make it do? That's up to you.
David Billia, shout out to him. He just got his level 3 cert with an 8-inch jumbo Dark Star. Pretty sweet. I think he did an M4500 too, which is pretty gnarly level 3 choice.
Nice.
He says, where should you start off doing this if you don't have a fume hood in your garage? Can you just work outside in a respirator and bunny suit? And then he asked what size motors to start with, but we kind of already addressed that. So
yeah, so the first off, almost nobody I know has a fume hood. Don't plan on buying one. If you find one for free on Facebook Marketplace, I guess I don't know why you would need one, but you know what? Go for it. No, but you should be mixing outside unless you have a large garage area that has big roll up doors that allow for a large amount of ventilation. That's the main one. So working outside would be my suggestion. If you are in a climate that's really hot, make sure you set up shade, both for yourself and for the propellant purposes. If you're mixing and it gets too hot, it can, just like with epoxy, it causes your curative to act really quickly. And so you may not necessarily want that as you're mixing. And then he also asks where you would find a mentor for making your own propellant, which is a really great question. The first place I would look is your local club, right? If you have a club that you fly with that's a Tripoli chapter or Tripoli prefecture, and some level 2 or 3 people, you see somebody fly an EX motor, introduce yourself, say hi, ask about where they might be in your area, and if they know anybody who might be interested. If that doesn't work for you, or you want to try another approach, you can just reach out to the club officers over email and say, hey, I'm interested in learning this. I'm looking for somebody who might be interested in teaching, anybody who would be available. If that doesn't work, there are copious amounts of online communities, namely the r/rocketry Discord. If you're listening to this podcast, feel free to throw a question in the Discord chat here. But there are lots of people all over that know a lot of people all over the US or even around the world that can be valuable and helpful in finding mentors for you. But very rarely do I find a situation where there is not a mentor a reasonable distance away from somebody who wants to learn.
awesome. This one's interesting, actually. I'm curious about this now. I never thought about it. Josh Sickles asked, what additives can you use to get different color smokes? We see black and white a lot, but can you make a propellant that produces a high volume of red, blue, or other smokes? And also, where does he get his good looks?
Well, same answer to that. My mom and dad. No, but it's a really good question, and one that comes up pretty often is why don't we see colored smoke? Right? You see colored smoke bombs, like smoke, charges that people have for either fireworks or just for strapping to their ankles during like a skydiving routine, or there are a couple examples, RC airplanes, where people have colored smoke and stuff. The challenge we have with our motors is that they burn way too hot. All of those smoke systems that you see that produce color are they're almost like mixing chalk into the propellant, and you're getting a very cool combustion temperature, probably under even 1,000 degrees in some cases. Our rocket motors just don't burn that cold, and they're going to burn really hot. We're talking 4,000 to 5,000 degrees is pretty typical. And because of that, if you were to try to introduce the materials that make a red smoke, let's say, into a rocket motor, it would come out totally not red at all. All of the chemical ingredients would get consumed and denatured, or well, I don't want to say burned is not the right word, but they will chemically alter themselves in a way that will not produce colored smoke anymore. And that's why we don't see it. If it could exist, it would have to exist at a much higher temperature than the typical propellants or the typical colors that we see now. And I would guess we'd see them by now. So I wouldn't say it's possible, unfortunately.
I do have to say, though, I've seen a friend of mine who does a lot of photography stuff had a couple of the just like 3-4 minute smoke charges, and they looked very similarly sized to a 54 millimeter motor case. So I was like, dang, we could like whip a couple of those in the outboard of the Arcus and just have smoke for the entire flight. It'd be kind of fun.
What would be interesting that I don't think I've seen before is to do that as the delay grain, or do that as the smoke charge for a motor. So when the motor is not operating at high temperature anymore. It can be just a smoke charge in the forward end that's burning at a much cooler temperature. I don't know if that's possible. I've not seen it tried, but maybe there's an avenue there for somebody who's interested in experimenting.
Yeah, you'd almost need a secondary ignition system to make that happen. But David is back. He says, how would you know what order to mix and match off-the-shelf propellant grains to if you want to make the motors that don't exist? Specifically, a pink or purple Sparky motor. I feel like it's safe to assume he's talking about the propellant grains you can just buy from RCS.
Yeah, I was going to say we didn't talk at all about simulating rocket motors and what kind of tools you can use. Just like we use Open Rocket to simulate our rocket's performance, Open Motor is an excellent tool, as well as BurnSim for developing and designing your own rocket motors. There's still, knowledge that you need to know going into using those tools in order to prevent, garbage in, garbage out kind of scenarios. But that being said, if you're interested in mixing and matching off-the-shelf propellant grains, that would be a good place to start, where Aerotech provides you all of the relevant properties for propellant, and you can go in and give it a try. In general, there's not too much risk associated with mixing various grains. The thing to keep in mind is if you have burn rates that are very different, that means those grains are going to burn out at different times. And if they burn out at different times, it could have different thermal problems in your motor. And so just like when you have something like, I believe the K375, for instance, has a single warp 9 grain with a bunch of white lightning grains. Really awesome burn profile. It's super cool and interesting. That first grain is going to burn out really quickly, and you're going to have a lot of excess heat getting dumped to the motor case, to the liner, right at that junction. And if you're not prepared for that additional few seconds where there's no grain anymore in that bottom area, then you want to be careful of that. But in general, have fun, try it out. You'll find in general that getting the exact color you're looking for is kind of tricky. Different ingredients dominate other ingredients in the chemical process of combustion. So that's why you'll see companies do like maybe only one blue grain with a bunch of red, or maybe 2 versus 3, or they're trying to balance and get the color they want. Too much red and it'll just look like a red motor. Too much blue, it'll just look like a blue. So finding that balance is maybe not necessarily 50-50. And if you're doing colors with something like a Sparky or whatever, you got to ask yourself how close you're getting to what I call the metal storm effect, where you're just not going to see the sparks really at all. And it's just going to be a cloud of white smoke that maybe sounds like there could have been a Sparky in there. That's something to try, and share your experiments with others and see what other people are doing, because it's a bunch of fun to see what other people try in the cool EX world.
All right. Yeah, shout out. There's a guy, I can't remember who it is, but he will buy like an L1520 and an not 1420, the
1120.
1150.
Oh, yeah.
And he'll just he does 2 3-grain loads, and he swaps 1 grain from each, so he just gets purple motors that he puts in Aerotech 3-grain 75 cases. Pretty cool. Brian Kelsey says, what is a spark moment that you say, man, I need to make my own propellant? Is it the frequency of flights, cost, or motor availability? And we kind of touched on this already, but he asks about your starting research point, books, classes, is starting size. Wow, we're answering a lot of questions ahead of the curve here, Bryce. He says, I'm a chemistry nerd, but I'm not sure I will someday go, yeah, I need to put several pieces of equipment, chemicals in my garage or basement. Don't do that. We already talked about that. And start mixing things up. Maybe sugars, sorbitol motors. That looks easy.
Yeah, so a lot of questions packed in there, Brian. Let's see. So starting off here, the spark, right? For me, my interest in doing EX is making motors that I can't buy. It's not necessarily about saving money, although that's a nice feature sometimes when you make your own motors at the cost of your time, of course. But that being said, for me, the spark was, hey, I want to make this motor, but it doesn't exist. Nobody makes a whatever it is, a high performance motor for the 38, 720 case. So I'd like to try doing that. Hey, nobody makes a high ISP motor with a slow burn rate. I would like to try making C-Star, but half as fast, right? Playing around with what I can make right now. Anybody who follows me on social media or talks to me about making motors knows I've been on a kick this year making a new formula I call Methalox, where it is a formula that is crystal clear. Looks like a liquid engine as it's firing. There is no smoke, not even a tiny lick of smoke. It is just an ultra clear, really bright, clear flame, a slight tinge of blue, and that's it. And it looks like the rockets are just levitating on this giant, huge flame, and no smoke whatsoever. Very strange to see at a solid rocket motor launch. Pretty common to see if you're used to watching, Falcon 9s and all the other commercial space vehicles that are using solids. But that was my interest was what motors can I make that I can't buy. Is there a frequency of flights, cost of motor availability? Yeah, to each their own, right? Motors are getting more expensive now. I'll admit the cost of ingredients are getting more expensive as well. Funny how those things line up together. And so with that, the cost of making your own motors has increased as well. Now, if you're like Braden or Taylor and I, and you remember back when you can buy, K motors for like, $120 or something. And nowadays you cringe every time you see like a 250 or 600, or like $300 K motor. You're like, the costs are lower, generally speaking, for the raw ingredients, and that eliminates that, startup cost we spoke about briefly. So yeah, if you're flying all the time, you and your friends want to make motors together, it is a way you could make money if you're not interested in pushing the envelope. If you push the envelope, you're going to break things, and breaking things costs more money. But if that's what your hobby's about, if that's what's really fun to you, like, do what you can and do it safely. Books, I talked about Terry McCreary's book. If you're interested in technical books, feel free to reach out to me. I have a little library here behind me that includes a lot of really wonderful books, like Sutton's Rocket Propulsion Elements is probably one of my favorites. Topics in Advanced High Power Rocketry is, or Topics in Advanced Model Rocketry is up there as well. Not a whole bunch of motor stuff in that, but anyway, there's some technical resource books as well that would be good to get in on if you're really looking to dive in deep. Making small motors, you asked about 24 and 29 millimeter motors. I'll admit I'm actually making my first 24 millimeter motor this month. I've never made a motor that small, and it makes me far more scared than it should, because I just don't know what I don't know about making small motors yet. And of course, as we talked earlier, it's kind of a test about how consistent and good propellant you can make, because you're susceptible to small changes. They make a big difference in small motors. So I'm pretty confident it's going to go without any issue whatsoever. But I would start with at least a 38 if possible, 38, maybe 54 if you can swing it to start with. And awesome, being a chemistry nerd. I'm not a chemistry nerd. I wish I was. It's very interesting, and I try my best to learn as much as possible. There are reasons I have plenty of textbooks and online resources at my fingers and disposal all day long in order to answer any chemistry question that I've got. So keep it up. There's a lot of cool chemistry involved, especially in the curing and resin side of things. So that's really fun. And I think we talked about everything else. Making sugar motors does look easy. And I'll punt it to whoever your mentor is to teach you the easy way to do it safely and correctly.
Cool. Bayou Rat says, sounds dangerous, but we've already addressed that, so we're going to move on. Bob Green asks, when starting to build your own motors, can you give some guidance on Bates grain sizes you suggest? Am I right in assuming gaining experience with the Bates grain is your recommendation? Quality control goals, unattainable dimensional consistency criteria that comes only with experience. Viewing videos, it appears that after vacuum degassing propellant is way harder to load into the grains or liner. Please comment on the trade-off between reduced workability, leading to propellant cracks and gaps, and not degassing and having micro bubbles in the final poured grain. And finally, do you sift the AP or oxidizer? If so, what micron size do you shoot for? Are you looking for a maximum size, or are you looking for a specific size plus or minus?
Whew, okay, good questions. Number one, base grain sizes. I'll admit I keep it easy. I just stick with what the commercial guys are doing. So if a 38 millimeter Aerotech reload uses, I should remember, 2.285. I don't remember anymore. Anyway, I have a spreadsheet that has all of the commercial grain sizes, and just sticking to that is just super straightforward. Loki Research also has a page that I reference frequently. That is their tech info page. And in the right-hand column of their each motor size, they list like, hey, this 75 6000 case would be a great with 5-6 inch long grains with a core of 0.625. Those offer really good starting places for pretty common propellants. If you're playing with really fast, really slow, something funky, you want to probably be aware of what changes to those you should be making. It's also a great place for a tool like Open Motor to step in and help you with that. But Bates grains are what 95% of people are doing. I'm mixing some cool Finicil grains, and you can do some other fun stuff, but it's got to be something you're interested in experimenting with. 3D printing has enabled us the ability to make a bunch of really funky cores for pretty cheap. So, have at it. These design tools have access to a lot of really crazy geometries, and learn about them. Figure out what makes them different. Why would I want to use a Finicil versus a Bates grain or a center perforated grain? What about a C slot? We see a lot of C slots in like 29 millimeter and smaller Aerotech. Why do they do that? Ask yourself these questions and play around in a sim, and you'll learn a lot from doing that and ask around. Quality control goals. My goals are typically 95% or better theoretical density. So if I'm making a motor where I get less than that, or I have a grain that's less than that, it typically will get chucked into the grain fire, and I'll save that for burning out in a campfire and not in a motor. Unattainable dimensional consistency criteria. Everybody has their own criteria for what they consider good enough. Most of my grains, even though I try really hard, don't look professional. Like, they don't look like an Aerotech grain off a production line. Hopefully they look pretty close, but they're never perfect, and that's good enough for me. I'm not, did my blade wander when I cut the propellant? Did I not chamfer the top end of each grain like Cicerone does? That's to each their own and what they consider to be their personal consistency requirements. Viewing videos, it appears that the vacuum degassing the propellant's harder to load. I'll say that's probably just a perception and not a reality. I've not noticed a major viscosity difference in a pourable propellant that's been vacuum processed. The big thing is you may notice that after the last mix and last vacuum, right? In the last step, you've already added curative. You're on the clock and things are going to start to harden up. And so the propellant is going to start to get more viscous over time. So depending on what videos you're watching, maybe there's a difference in the time that you're seeing where the propellant is going from not vacuum to vacuum, but really there's also curative and time that's passing or other ingredients that are being added. But it's typically not a big concern. I don't sift my AP at all. I don't sift almost any of my ingredients. Well, that's not totally true. I should be clear. I don't classify, which is the right word, I think, for what they're trying to describe, where you're picking what particle sizes of your ammonium perchlorate or your aluminum or your other ingredients. You call it classification, where you take different levels and different sized sieves to filter out, let's say, particles that are too big, particles that are too small, and kind of getting a narrow band in the middle. I don't do that a whole bunch. I'm pretty happy trusting my AP sources to just deal with what they give me. But what I do that is important is I do sift my propellant, or my ammonium perchlorate in particular, through a fine metal mesh, just to break up chunks and catch any foreign debris if there is any. I don't tend to have that issue, but depending on where you get it, maybe that's more of a problem, especially fine AP, the 90 micron. I store my ingredients in a temperature and humidity controlled room in order to prevent high humidity. I live in the Pacific Northwest. It wasn't a problem when I lived in Arizona, where we had, single digit humidity most of the year. But here in the Pacific Northwest, where it is just regularly very high and very high humidity, I keep my propellant as dry as possible. And then there's desiccant bags and stuff as well, but that doesn't prevent the clumping in its entirety. So I want to make sure that I break those particles up as best as I could before putting them in my mix. But I don't have a specific size for that.
Cool. Jack Pullman has two slightly shorter winded questions. He asks, what is the most challenging EX record to attempt and why? And single throat or Medusa nozzle?
Single throat for me. Medusa is cool, but it exists purely as a manufacturing outcome. It's really easy to make a single Medusa mold and make a hole just in the middle for your 1 grain and 2 grain motors, and open up all 7 holes for your 6 and 7 grain, 8 grain motors. And so it's a really great manufacturing tool that most EX people don't have any care in the world for. You're going to be either using graphite nozzles or you're buying RCS nozzles, and nowadays they have single throat nozzles for all of your purposes. So they're cool, like in concept, and I definitely appreciate the manufacturing production mindset that went into their fabrication and design. But single throat nozzles for the win, absolutely. Most challenging EX record to attempt is an interesting one. For those who don't know, I also, I'm now a board member for Tripoli, but before I was a board member, I was and still am one of the members of the Tripoli Records Committee. And Tripoli documents 2 different categories of experimental motor records. One is the individual set and one is the group set, meaning one is the individual flies the rocket and makes the motor. One is a combination of people build the rocket, build the motor, fly the rocket, do some combination there. And it's a team effort, essentially. And for each of these, there are 15 divisions between 24 millimeter and greater than 6-inch diameter motors. And it's broken up by motor case size. So there are 15 of those. So between the 2 categories, teams and individual, there are 30 potential records. Of those 30 records, less than 5 are taken at all, period. Which is outrageous because people fly EX all the time, which means your goofy, 1,000-foot flight on your EX motor just set a Tripoli altitude record, more likely than not. So what is the most challenging for me personally? I'm most scared of the 24 millimeter individual EX record, because I've never flown a 24 millimeter rocket with motor ejection, with electronic ejection. I've never flown a rocket like that with a recording altimeter in size. And so for me, that's where I'm uncomfortable with. Now, I have to admit, flying a motor bigger than 6-inch diameter is also pretty freaking intense. And so there are definitely a lot of challenges associated with setting those altitude records as well. But that would be for anybody who's listening that has done or does do EX or wants to do EX, please go submit Tripoli altitude records. Go check your categories available. It likely is, and fill up the record boards. Fill them up, please.
No, I was gonna say it's not exactly a public project. Patreon people know about it, but maybe next year, if it's not taken, we talked about this briefly, Bryce. We could potentially have the group 6-inch or bigger record, at least for a while.
Ooh, exciting! Yep, I'm good with that. I'll tell people here, I have a group. In fact, Jack is part of the team that's coming out next month at our regional launch we call Sod Blaster up in Pasco, Washington. where we are going to attempt to set all of the 98 millimeter and below group records.
Oh,
So
Oh
there
my
are
God.
8, I think, open categories in that group, and we want to set all of them. And they're not going to be very high, but they don't have to be because there are no records in those categories. So we don't have a high waiver. It's only 9,000 feet, which is great, but not very high for setting high performance altitude records. And so, so we have a team of people, about 6 or 7 of us, I think, that are going to be making motors and flying rockets and setting, hopefully, if everything goes according to plan, we will fill up all of the 98 millimeter and below group records. And the bar will be set low enough, don't worry, that anybody who wants to break the record can definitely break the record. So have at it. And that's the thing I'm working on right now.
Awesome. We're looking forward to seeing that. Bayouret is back, says, why use Tepanol?
Yep, Tepanol is a pretty important ingredient, but not one that is necessary for most people. So in this ingredient, you use it in very small quantities, typically like 0.3% or so by mass. And when you use it, what it's doing is it is enhancing it etches the outside of the little ammonia. If you think of the ammonium perchlorate molecule set, the like actual particle that you're dealing with, the macroscopic particle, and what Tepanol is doing is it's biting out the outside. It's activating the outside of the particle like sandpaper would, allowing the HTPB to grab on and hold on to that particle and not letting it out. So normally the particles are pretty smooth, and if they're smooth, you can almost take your fingernail and you can scratch at the propellant and you can have the little globs of AP just kind of pop out. Well, that's not ideal, and it can affect your propellant strength and a number of other properties, especially at higher pressures or at higher accelerations. And what Tepanol does is it allows the HTPB to bond to the ammonium perchlorate and hold on. And if you have really big particles, like 400 micron sized ammonium perchlorate particles, it can be really important to use Tepanol to jump in there and really hold on. Otherwise, all that AP is just going to start spraying out, and you can have a lot of problems during a burn. That being said, if you're not flying really high performance, if you're not using a lot of 400 micron in your propellants, and you're not flying high acceleration, generally speaking, it's not super necessary. And so if you can't buy it or your stock is really old, don't worry about it unless you're really cutting the edge of performance. Yeah.
Quentin Troll says, is flying EX regularly generally cheaper in the long run than flying commercial motors? I've heard mixed information on that front.
Yeah, I would answer that question with yes. Is flying EX regularly generally cheaper in the long run? Yes. In the long run, it is pretty hard to argue, in my mind, that it's not cheaper. Once you get past the upfront costs, once you start thinking about larger motors, if you're flying 75 and 98 millimeter motors a few times a year, right now I just, for an example of costs, right? And this is just one example. Everybody buys ingredients from different sources. Everybody has their own different costs that they roll into what they're making. But I just made the equivalent of like an N2000 reload. And in that N2000 reload, it's a 98 6-grain motor. It uses roughly 15 pounds of propellant. My propellant costs and my nozzle, liner, casting tube, other consumables, O-rings cost rolls up to be a little under $400. It's like $360 or so. Well, it turns out that a N2000's like roughly $900, I think, $860, $900.
13.
Oh God, that makes my brain hurt. Maybe I was thinking the M2500 there. That's right. I was actually, because I just had to do something for someone else for that. But yeah, like $1,300. Like that's a lot of money. And so, if you have to buy the ingredients and there's a lot of casting equipment and stuff, like, sure, it's not going to be cheaper the first motor you make. But if you're making those motors regularly, you can definitely see some savings over time. Especially if I got to be clear, if you're not pushing the limits and you're not breaking things. I just had a friend of mine misassemble an EX motor, unfortunately. And when it let go halfway through the burned a hole right through the side of the case, right through the side of the rocket. It was a total loss. And it was a problem that probably would have happened even if it was a commercial motor. It was just, simple mistake when assembling the motor. But chalk that up to whatever situations you're assembling motors in. And, would it have been cheaper for him to fly an N2000? Maybe if that was assembled different, it could have been. But that's the risk you take. And in general, I find that it works out much better in the long term if you're willing to stay with it and you're making motors with that in mind. Then you can save money for sure.
David Bratz or Bratz, I never know. I'm sorry if I'm pronouncing your last name wrong. What myths about mixing and motor design should be put to rest? Any other hot takes on common EX practices or rules of thumb? Have you experimented with mechanical accelerants like wire or chopped carbon? Any thoughts on those methods? And what new technologies for the amateur rocketeer excite you? Spin cast liners and homemade COPVs have piqued my interest as new improvements to performant EX motors.
Lots of really cool questions in here. So what myths about mixing and motor design should be put to rest? I'm in the process of trying to compile a list of what, rules of thumb exist for making motors. Things like, something we call the port to throat, the ratio of the core empty space to your nozzle throat empty space. Having that be a ratio of at least 2-to-1, making sure your throat's smaller than your core. Rules of thumb like don't exceed 2. I always get the units wrong for mass flux. It's going to be pound mass per second per inch squared. Don't exceed 2. Fine, that's a great rule of thumb. It helps keep some things away, but it's not a an exacting rule, and your propellants are going to be different. So there are a number of kind of rules of thumb in this realm that are really good and really helpful if you don't ask enough questions. Like, just follow them as gospel, and you'll probably get pretty far. But I'm interested in kind of learning more about each one of them and breaking them each down technically. And pushing the limits just a little bit and see where they actually start to run into issues. You asked about any specific hot takes. I love when people ask for hot takes because it just feels like you really put on the spot for like, hey, can you just ask people to be mad at you really quick? Which I'm not super interested in. So I don't think I have a particular hot take at the moment. The big one that comes to mind is just all the YouTubers that are making sugar motors and making tutorials that make it seem like they have all the info available to them. If you're young and you're impressionable and you're watching that stuff, I get really worried about the safety that people have. And I see it time and time again as a moderator for online communities. If there's a hot take I'm allowed to, then I'm just going to take down the king of random you smoke rocket candy video because it would save me hours a month of moderating kids doing unsafe stuff, and I just don't want to see that. It's not good for them, it's not good for us. And so that's my hot take. Give me permission to take down bad sugar motor videos on YouTube and I'd be happy. Have you experienced with any experience with mechanical accelerants like wires or chopped carbon? I mentioned some of them earlier. I would like to experiment with running wires or chopped carbon through motors. And what we're talking about here is a mechanical burn rate enhancement. So I want to make my motor burn faster. What can I add as an ingredient to make it burn faster? Not just chemically, but actually mechanically. So we're actually taking little piece of carbon fiber and mixing it into the propellant, like the world's worst dog booger when you're like mixing epoxy and you've got the chopped carbon. If you've ever mixed chopped carbon in epoxy, it's like the worst thing in the whole wide world. Well, you could do the same thing with propellant if you want, and try to pack a propellant with as much chopped carbon as possible. And the wires do this, copper wires or silver wires will do the same thing, where what they're doing is they're enhancing the speed at which the propellant heats up, and so it's causing a bunch of extra propellant to get really hot and burn along the grain. So really interesting, really cool stuff. I'd love to play with it more. It's not something I'm currently doing, but I would like to. And I'll definitely echo the homemade COPVs as being really cool tech. The main thing that's not really a new technology, but a new capability for the average or beginner EX person is being able to go to RCS and just buy whatever rocket motor component that you need to go make a single-use motor. You could buy all the ingredients to make your own DMS without any risk to hardware, without any risk to damaging, the hardware is expensive. And so you don't want to just throw it all out on the line. If you're going to try a new experiment, like you want to play with chopped carbon fiber, it could be risky. You could get a really high burn rate, or maybe it's nothing at all. And so being able to play around with the RCS components has really, I think, lowered the barrier to entry to people to be able to get liners for what they need, casting tubes for what they need, single-use nozzles, O-rings, all that kind of stuff that you used to have to shop around for, or you were had to get really involved in the graphite motor, side of snap ring hardware. That used to be really common. Almost all of my EX motors, 90% of my EX motors, are reloads that I make in a commercial Aerotech, case. Because it's just easy. They've lowered the barrier so far that it's easy for me to just buy. If I'm making that N2000 clone, motor, I'm just going to pick up a casting tube, a liner, and a nozzle from RCS, and there we go. I now can make my own propellant, cast it in the casting tube, cut it up in the geometry I want, and off we go. I'm flying motors in a way that is very familiar and comfortable, and that's comfortable and familiar is safety to me. So that's maybe not new technology, but it's something I'm really excited about. And Gary doesn't have to make all of that available. He doesn't have to give you every motor design and cross-sectional drawing. He tells you what every grain length is, every core diameter, every nozzle diameter for every single motor they manufacture, including DMS, including motors that are yet to be released, including motors that will never be released for reasons that are complicated. But all the designs are there for you to go have some fun, learn something, try things that are new, and the barrier to entry is just so low. That's where I always send people to get started in buying their consumable products.
Yeah, it's crazy because mixing motors for Aerotech hardware used to be like entirely unheard of. It was all snap ring stuff. So it is crazy to sort of have this new wave of just like people loading up Aerotech stuff. It's super cool, but it is a lot more expensive if you do some damage to said hardware. At least if you're replacing it new. But if you find it for free on Facebook Marketplace,
there
great
you go.
Deal. Our final question for the evening comes from Bob Green. Since no one asked it above, KNXX propellant, any pros other than barrier to entry? Would KNSU or KNER in proper aluminum cases be a reasonable way to see if I like making my own motors? I have no idea what he's talking about.
I was trying to see if maybe I have to refresh here to get it. It sounded like these were, you said KN means potassium nitrate, which almost always will mean a sugar propellant of some kind. So,
I guess that's what KNSU probably
sucrose,
is. KNER?
Erythritol.
Right, okay.
Erythritol. It's another sugar. So.
Okay, so all right.
Yeah, sorbitol is common.
Yeah.
So that's, it looks like, KNER, KNSU, all common propellant types for sugar. And so I think I've kind of talked about that. In a proper aluminum case would be a reasonable way to see if you like making your own motors. Maybe it's not very common. It's not very there's not a lot of commonality with making ammonium perchlorate motors, just in terms of the process. Designing the motors, there's a lot of carryover. But in terms of like the actual, like, do I like having a hot plate around and casting brittle propellant into tubes and stuff? Like there's some aspects of that don't carry over, and you may like one more than the other. There are obviously lots of people that really like sugar motors, so I'm not saying that's a bad thing. But is it a reasonable way to see if you like making your own motors? Maybe. I don't know. Give it a try. Do it safely. Do it with ask some questions. Do it with somebody who's done it before, and there you go. I think that would be a great place to start. I see one other question Bob threw in here as well. Have you tried?
Oh, yeah, new one.
Bob Green asked, have you tried either polyethylene glycol or propylene glycol as a replacement in part or entirely for HTPB? I have not. HTPB is just too regular and common and easy to get, and it performs great. So I have not played around with any silicones or epoxies or any of these glycols as a partial or entire replacement for HTPB. So yeah, that is our question set.
Bryce, thank you so much for being here. Thank you for fielding everybody's questions. It was awesome. And I know, like you said, people feel free to reach out to you on Discord. Yep. Bryce loves answering people's questions. Just don't ask him about making sugar motors on your stove, just in your normal kitchen. Yeah, is there anything else you want to throw it to before we exit the stage?
I was just going to say, plug some socials really quick. The best ways to get a hold of me are on Discord through my username @mod_Bryce. The other way to get a hold of me if you're on Instagram is @rocketsandrandomness. I don't post there frequently, but it's a fine place to ask questions or see what big projects are coming through the pipes, because there are a lot of fun projects in the works for sure.
Awesome. Well, we love to see big rockets. There's no secret in that from the Anti-Gravity Group. I think Matt may be hooked now enough that we need to plan a full AGG trip to Bryce's house to learn to mix propellant.
Let's make a whole EX load for the Punisher.
Let's do it.
Oh, yeah. Taylor's going to be a tough sell on that one. But we could probably do the Arcus. He loves the Punisher too much. He doesn't trust anybody to make propellant.
We'll do it right the first time. It'll be okay.
Porthos too is getting some EX. So.
Oh, you're going to make Taylor cry now.
He's going to be so happy when he sees it live. He'll forget all of the sadness.
All right. Well, my name is Braden Carlson. You can find me right here on YouTube at Rocket Vlogs. You can find me on Instagram at BigB1011 and TikTok at Braden Carlson. Postart 6. Okay, there's a number. I didn't pick the username, but I'm at 7,000 followers. I'm trying to get to 10. I don't really know why. Oh, I guess I can be monetized. I do want to make another 30 cents per video I post, so please go check me out on TikTok.
My name is Taylor, and you can find me on YouTube at The Rocket Channel.
My name is Shane, or Postart. You can find me on YouTube at Postart Propulsions, or I guess Instagram at Shane Harris Photo if you want to see pictures.
I'm Matthew, and you can find me right here.
We are the Anti-Gravity Group, plus Bryce Chanes today. This is the Anti-Gravity Group podcast, and we will see you all next time.